If I can't picture it, I can't understand it. Albert Einstein. Welcome, students. Today in Newton's law, we discuss two and three block problems. Here on the diagram, you can see in first setup, two blocks A and B. They are placed on a horizontal floor, and a horizontal pull F is applied on the block A. The pull may be applied either on the block B, or it can be applied simultaneously on both the blocks in the same direction or in opposite directions. And there may be friction between A and B, or B and floor, or there may be friction everywhere. Similarly, in the second situation, you can see three block setup. Here, blocks A, B, and C are placed one above other. And in this situation, a horizontal pull is shown to be applied on the block B, but in situations, it can be applied on block A, or it can be applied on block C, or it can be applied on the blocks simultaneously in the same direction or in various directions. Actually, taking decisions of friction forces acting on these situations, and especially where the sliding will begin first and especially sequence of sliding, these decisions are very tricky and they require very critical understanding of frictional phenomena, especially static friction. Actually, what I personally feel, in any sensible examination, such kind of tricky or puzzling problems are not suitable. But as a practice, if you are comfortable to think solution of such problems, then rate yourself that you have understood friction very well. That's why I'm taking these kind of problems separately in one lecture today. So before we start with any of the problem, let us revise what we have done earlier. Especially, we have made some strategy of deciding friction and sliding. Say what the ideas are. First, let us see very important definition. What is sliding? Sliding is a relative motion in contact. Actually, when two bodies are in contact and they have relative motion, they are sliding on each other, especially relative motion, translational motion only, then there will be sliding. Here, static friction. Its magnitude and direction are adjusted to oppose tendency of sliding. Actually, static friction is very mysterious force, or sometimes we call self-adjusting, and that's why it is called self-adjusting. Its magnitude and direction both will adjust to oppose tendency of sliding. Its magnitude remains in between 0 to mu s into n. Here mu s is the coefficient of static friction and mu s into n is called the limiting friction or maximum value of static friction. Now kinetic friction. It always acts on a body opposite to its velocity relative to the other body in contact. Basically, there must be sliding. So as far as kinetic friction is concerned, its direction is apparent. You can see the sense of sliding or direction of sliding, and you can find the direction of kinetic friction. And its magnitude is again very straightforward. It is constant. That is equal to mu k into n. Mu k is coefficient of kinetic friction. So if you see here, kinetic friction, where it will act and in what direction it will act and what will be magnitude, this decision is very straightforward. But you have to think very critically in case of static friction because it is self-adjusting. It opposes tendency of sliding, and tendency of sliding is not visible. In some cases, it will be apparent. In some cases, it will not be apparent, and where it will not be apparent, care has to be taken to decide the sense of tendency of sliding. Again, one thing, mu k, coefficient of kinetic friction, is always less than is equal to mu s, coefficient of static friction. How to estimate direction of friction? That is again important. Now, step 1. If sliding or sliding tendency is apparent, direction of friction is obviously opposite to sliding or tendency of sliding. But if bodies are not sliding and tendency of sliding is not apparent, estimate or calculate accelerations of the bodies under study, assuming no friction at the contacting surfaces under investigations. Now what we do? Suppose if sliding direction is visible or apparent, or tendency of sliding is apparent, then there is no problem. But sometimes it will be difficult to estimate tendency of sliding. In which case, what you to do, what is recommended? The most straightforward method is what? Calculate accelerations of the body under consideration or under study, assuming friction to be absent and the contacting surfaces under investigation. In this way, you will be able to find accelerations. And now what we will do in step 2, now estimate or calculate their relative acceleration to find sense of sliding. Direction of friction is opposite to the sense of sliding. Now, these accelerations, their relative value, will give you indication of sliding sense or sense of tendency of sliding, and accordingly you can decide direction of force of friction. How to decide magnitude of friction? Till so far we have seen how to decide direction of friction, especially in case of static friction. Now turn is to decide magnitude of friction. Here two distinct cases may appear. In one case, the bodies under study are sliding. That is very straightforward. There will be kinetic friction. And in second case, the bodies under studies are not sliding. It is apparent this case of static friction, but it requires some attention. Now see the first case. Bodies under study are sliding. Kinetic friction must act to oppose sliding, and its magnitude is constant. Fk is equal to mu k into n. Now second case, if it is not sure that the bodies under study will slide or not. Here first we take a very special case, a body kept on inclined plane, and it is intended to slide due to gravity only. If the body under study is on a stationary inclined plane and it is not sliding due to gravity only, in this case, angle of inclination will be angle of less than or equal to angle of repose, and that is again equal to angle of static friction. Now in other cases, for other situations, we decide the strategy in two steps. In first step, what we do, calculate the limiting friction FSM and friction FRE required to prevent sliding. Please take care. What we do, we first calculate the limiting friction and we calculate the friction required to prevent sliding. And now, according to cases, step 2, if there is no sliding, and second, if there is sliding. If there is no sliding, the friction required to prevent sliding will be smaller than the limiting friction. FRE will be smaller than limiting friction, and this FRE will be equal to force of static friction. Fs is equal to FRE. And here you can see when we calculated required friction, direction we have calculated already. Now if there is sliding, this FRE will be greater than FSM, and here there will be kinetic friction. So Fk will be equal to mu k into n. So that is what complete idea or complete strategy to decide friction. Now we come on the types of problems what we have at hand today. Example 1. First we take very simple case, two blocks A and B of masses 5 kg and 10 kg placed on a frictionless horizontal floor are being pulled by a gradually increasing force F applied on the block A horizontally as shown. Coefficients of static and kinetic friction between the blocks are 0.5 and 0.4. And here what is said, the floor is frictionless, and the situation is this way. Here we can see the block A and B placed one above other on a horizontal floor that is frictionless, and there is friction between blocks A and B, and the coefficient of frictions are given 0.5 and 0.4. 0.5 is for static friction and 0.4 is for kinetic friction. And what we have to calculate? Draw a graph between accelerations of the blocks and the applied force F. It means we have to explore the accelerations of the blocks for the range of force F from 0 to sufficiently large value when there will be sliding between the blocks. Now, how we think about solution? First thing, to decide direction of frictional forces. Here, the direction of frictional force is apparent. What if it is not apparent to you, assume friction to be absent here in this block, because what we have decided, where we have to decide tendency of sliding, assume friction at that contact to be 0, not anywhere else. But here friction is given 0. Now if you apply force F, this block A will start accelerating forward and the block B will be stationary. So you can see the relative acceleration. So relative acceleration is what A is horizontally towards right and B is stationary. So you can see the tendency of sliding, but we cannot say whether there is sliding or not. So clearly friction on A will be in backward direction and friction on B will be forward direction, because friction between two contact surfaces makes Newton's third law pair. Here, sense of sliding or its tendency is apparent. Thus, directions of frictional forces on both the bodies are shown, say this way. So here is the situation. Now we apply force. So friction will be in backward on A and forward on B. So in this way, we have shown the direction of friction. So in situation, the first step is to decide direction of frictions. Now we think what will happen. As the force F increases from 0, both the blocks accelerate with the same acceleration till sliding between them initiates. Means till sliding between the block will initiate, both the blocks will move with the same acceleration. When sliding between them or the blocks is about to initiate, the required frictional force achieves its limiting value. Thereafter, accelerations of the blocks, both the blocks, will become different. Now, when the sliding is about to occur, at that time, this frictional force will be equal to limiting friction or force of maximum static friction. And even if you increase the force F thereafter, the sliding will begin and both the blocks will move with different acceleration. So what is the situation? All the possibilities we have think. Now we come for what? With the calculation of that is when the sliding will begin. So limiting friction between the blocks we calculate first, and then we calculate friction required to prevent sliding. So limiting friction is very straightforward. FSM is μs into MAG, because here is the friction and here's normal reaction will be equal to weight of the block. Now we are in a position not to show all the forces in free body diagram. We only show the required forces. So in all the situation, there will be no motion in vertical direction. So in all the abilities, we omit to showing vertical forces. So here it is very straightforward, limiting friction. So putting the values, FSM is equal to 0.5 into MA is 5 kg and acceleration G is 10. So this will be FSM is equal to 25 Newton. So limiting friction will calculate. Now next step is what? To calculate friction required to prevent sliding. The force F when sliding between the blocks initiates. For this, what I said, we decide the friction required to prevent sliding and we compare it with the limiting friction. Both the blocks have the same acceleration with the frictional force between them at its limiting value. Now, when sliding is about to occur, at that time, what will be? Both the blocks having same acceleration and friction required had reached its limiting value. This condition we implement here. So NLM, the system of both the blocks. So here no need to show internal forces, only this external force horizontal. We are not showing the external vertical forces. So this will be equal to what? Mass of both the blocks MA plus MB into acceleration. So 5 plus 10 into A. So you can calculate acceleration. So A is equal to F upon 15. Now NLM on the block B, because block B is moving only because of acceleration. Again on block B there is single force. So discuss this is simpler. So if you apply the Newton's law here, this is a force of static friction, we assume limiting friction. So that is what? Condition of initiation of sliding. Now here again we have not shown the vertical forces, that will be equal to mass of block B 10 into A and acceleration will be same. So what we can write here, A is equal to 2.5 meter per second square. From above two results we get, just we equate these two, what we get? F is equal to 37.5 Newton. So when the applied force F will become 37.5 Newton, the friction here will reach the limiting value and the sliding between them is about to occur. Now if we increase the friction slightly about 37.5 Newton, slightly means even by infinitely small amount, the sliding will initiate or sliding will become, and both the acceleration of the blocks will become unequal. Accelerations without sliding between the blocks. So what we write, when there is no sliding between blocks, the acceleration we have write from this value. So A of A is equal to A of B is equal to F by 15. For all values of F less than 37.5, let us call this equation number 1. So that is an important result when we try to draw the graph. Accelerations with sliding, when the blocks are sliding, how we find? There is a force of kinetic friction, first thing. So forget about this force 25 Newton. We calculate the force of kinetic friction and we assume these two forces acting on both the blocks. So now F is greater than 37.5 Newton and friction is kinetic. So Fk we calculate mu k into ma into z. Mu k is given 0.4 and m is 5 and g is 10. So this is what you can see 20 Newton. Now acceleration of the block A. So we draw the FBD. So applied force F and there is kinetic friction. We are not showing the vertical forces. So here this equal to 5A of A. So you can write A of A. F minus 20 is equal to 5 A of A. So A of A is equal to F upon 5 minus 4. Let us call equation number 2. Now it is remaining to decide acceleration of block B. Acceleration of the block B, we show the force acting on. There is only one horizontal force, force of kinetic friction in forward direction. So this will be equal to mass of the block 10 kg into A of B. So that is straightforward to write A of B is 2 Newton. So we have these three results. Now we can write all these three results simultaneously, writing results of equation 1, 2 and 3. A of is equal to A of A is equal to A of B is equal to F by 15 when F is less than 37.5 Newton. And A of A is equal to F by 5 minus 4 and A of B is equal to when F is greater than 37.5 Newton. So this function, now we are in a position to draw the graph. So here the above results are shown in the adjacent graph. So here on the ordinate we are showing acceleration. So A upon meter per second square, you can see A italic, so it is a represent a physical quantity and these symbols are straight, so this represent a unit. And here F upon Newton. Actually these are the standard notation of showing quantities on the axis of graph according to SI. Because axes on the graph are purely number lines, they cannot show any physical quantity. They can represent only numerical values. So we have to convert the physical quantity into numerical value. The straightforward way is what? Divide the physical quantity by its nearest. So what is remaining? Only its numerical value. Similarly here the numerical value of acceleration and here is numerical value of F. So here we have shown 10 Newton, 20 Newton, 30, 40, 50 and 60 Newton. And here accelerations are shown 2 meter per second square, 4, 6 and 8. Now for the range, F is less than 37.5. So this is equation F by 15. So it will pass to the origin and in this way. So here is 37.5. And when the force is 37.5, what will be acceleration? 2.5. So this graph will extend from this point to this point. Thereafter, acceleration of block B will become constant 2. And acceleration of block A is given by this equation. So we draw these two equations. This is acceleration of block A. So what is the minimum value of acceleration of block A after sliding starts? Because now the force is kinetic. So there will be discontinuity here. So when F is 37.5, what it will be? You will get is 3.5. And acceleration of B is what? 2. So when kinetic friction and static friction coefficients are unequal, you will find this discontinuity here. But if they were equal, here you will not find discontinuity. This graph will be here and this graph will start from here. We will see in some later problem. So in this way, we have shown the graph for all values of F. Actually, I have taken here specially the graph, but in some situation, you may be asked that what is the acceleration of block and force is 14 Newton. Even to solve those problems, what you do first, you have to decide all the things. when and where sliding will initiate. So that is what complete strategy to solve this problem. Example 2. Two blocks A and B of masses 5 kg and 10 kg are placed on a horizontal floor as shown. Coefficients of static and kinetic frictions between the blocks are zero point 0.5 and zero point 0.4. The floor is frictionless. A gradually increasing horizontal force F is applied on the block B as shown here. Now setup is same, but now we are applying force on the block B. In previous example, we have applied this force on block A. What you do? Draw a graph between accelerations of the blocks and the applied force. So again we do the same problem, but the force is now applied on the lower block. So let us see where will be difference. But again I am stressing on the strategy what we have adopted in the previous problem. First we have decided direction of friction. Then we have logically thought all the possibilities what will happen. Here it was very simple. In the previous case, again in this case, what is the future sequence of events will be very simple. What initially when the force is being increased from 0, both the blocks will accelerate simultaneously together with equal acceleration till sliding between A and B will start. Thereafter acceleration of both the blocks will become unequal. Now the moment when sliding between A and B is about to start, at that moment friction between them will become limiting static friction, and thereafter it will become kinetic and acceleration of both the blocks will be different. Now how to decide? The important thing was how to decide when the sliding will initiate. The condition is what? At that time or at that value of force F, the required friction to prevent sliding will become equal to friction limiting value. So let us proceed with the solution again. So first thing is what? We decide direction of friction. Here sense of sliding or its tendency is apparent. Thus directions of frictional forces on both the blocks or bodies are shown in the diagram here. See, if this is pulled here, now it is apparent because friction will act here on opposite direction, backward, and on A forward. But if it is not apparent, you can use the strategy what? Assume friction to be absent here. So this force F will accelerate block B and block A will remain there. So the sliding tendency will be apparent. So here friction on block B in backward direction and friction on block A in forward direction. So we have decided direction of friction. Now we think the future sequence of event. As the force F increases from 0, both the blocks accelerate with the same acceleration till sliding between them initiates. And what will happen when sliding is about to initiate? When sliding between the blocks initiates, the required frictional force achieves its limiting value. Thereafter, accelerations of both the blocks will become different. So this is the condition. At the time or at what value of this force F, this friction force will become limiting friction. That is what? Condition of sliding. So we'll do it. For that, we have to decide first limiting friction. So let us calculate limiting friction. Limiting friction between the blocks. So FSM is equal to mu S into MA into G. It is again the same. So mu S is 0.5, MA is 5 and G is 10. So it is 25 Newton. So FSM is 25 Newton. Now what we do? The force F when sliding between the blocks initiates. We know that when sliding is about to occur, the friction required to prevent sliding has achieved its limiting value. So the friction required we assume limiting and we'll calculate the force F. Both the blocks have the same acceleration with the frictional force between them at its limiting value. So for this simple thing is what? Apply Newton's law on both the blocks system at once. So NLM on the system of both the blocks. Here we show only the external horizontal force, that is only F, that is equal to mass of A plus mass of B into A. So 15A. So F is equal to 15A. So A is equal to F by 15. So one result. Now we apply NLM on block A. You can apply NLM block B also, but applying NLM on block A will be simpler. So because there is only single force of static friction in forward direction. So static friction is 25N. So that will be 5 into acceleration. 5 is the mass of block A. So A is what? Again here 5. Now from above two results we get, just equate them. So what we have, F is equal to 75 Newton. So when the value of force F becomes 75 Newton, the sliding between the blocks initiate, and for a greater value of force F, the acceleration will be different, and for smaller value of F than 75 Newton, the accelerations will be the same. Now we can explore the complete problem. Accelerations without sliding between the blocks. So that is very simple. A of A is equal to A of B is equal to F by 15. So that is one equation. For all values of F less than 75, let us call equation number 1. Accelerations with the sliding between the blocks. So for that we have to consider both the blocks separately with the forces of kinetic friction acting between them. Now F is greater than 75 Newton and friction is kinetic. So Fk is equal to mu k into mag. First we calculate the force of kinetic friction. So that is 0.4 into 5 into 10, that is 20 Newton. So kinetic friction force is 20 Newton. Now acceleration of the block A. So block A we say only there is a force of kinetic friction acting in forward direction. So that will be equal to kinetic diagram 5 into A of A. So A of A is a constant, that is 4 meter per second square. Let us call equation number 2. Now we calculate acceleration of block B. Acceleration of the block B. So on block B there are two forces. Force F is in forward direction and kinetic friction in backward direction on the top surface. So here 20 Newton backward kinetic friction and F. Or now we draw the kinetic diagram, that is 10 into A of B. So A of B is again very simple. F minus 20 is equal to 10 A of B. So A of B is equal to F by 10 minus 2. Let us call equation number 3. Now we can combine the results of all these three equations 1, 2 and 3. Writing results of equation 1, 2 and 3, what we get, A is equal to A of A is equal to A of B, F by 75, 50 Newton. When force is less than 75 Newton. And A of A was 4 and A of B was F by 10 minus 2 when F is greater than 75. Now these function we can represent in a graph. The above result are shown in the adjacent graph. Now just see, again we show that is acceleration upon its unit and force upon its unit. So in this way we are showing only numerical value of acceleration on the ordinate and only numerical value of the force on the abscissa. So you can see the values 20, 40, 60, 80, 100 and 120. So 75 will be somewhat here. So at 75 Newton, this here, the graph will become discontinuous. So till 75, this equation we have to plot. It will pass through the origin, so this way. So you can see when force is 75, when sliding initiates, the acceleration of A and B both will become equal to 5, and till then acceleration of A is equal to acceleration of B, and thereafter discontinuity in the graph will happen. Thereafter, when F is increased beyond 75 Newton, acceleration of A will become a constant 4. So we can show here, this is, you can see 4 acceleration of A, and acceleration of B will be given by this value F by 10 minus 2. So this is the equation. Now you can see the starting point when F is 75. So 7.5 minus 2, how much? 5.5. So it will start from this acceleration and its slope will be certainly greater than this slope. You can see here slope of this line and slope of this line. Slope of this line will be greater than slope of this line. So in this way, we have explored all the possibilities. Now, as I had told you earlier in the problem, instead of asking graph, it may be asked acceleration of blocks at a particular value of F, or it may be asked at what value of F sliding between the blocks will initiate. Suppose it is asked acceleration of the blocks at F is equal to 25 Newton. Even then you have to first decide when sliding will initiate. So we have calculated here sliding initiate at 75. So if it were asked to calculate accelerations of the blocks at f equal to 25, it means we know both the blocks are moving as a single unit. So acceleration will be given here by this 25 by 50. Now suppose if it were asked acceleration of the blocks at f is equal to 100 Newton. So even for that we have to decide first when the sliding will initiate. So we have seen sliding initiates at f equal to 75. So 75 is less than 100. So here are the result. So this is the equation under consideration. So f equal to 100 Newton, what will be a of a 4 and a of b 100 by 10, 10 minus 2, 8. So in this way you have to calculate. Now let us come on some other problem. Example 3. Two blocks A and B of masses 10 kg and 5 kg are placed on a horizontal floor. As shown, coefficients of friction between the blocks is 0.6 and between the block B and the floor is 0.3. A gradually increasing force horizontal F is applied on the block A. Now what we have taken one thing, we are considering friction at the floor also at the same time. Just to avoid complexity and calculation, we are assuming static friction and kinetic friction to be equal. So situation is given here. The force F is applied on block A. Draw graph between accelerations of the blocks and the applied force F. Now strategy will be the same. What? First we decide the direction of friction. Then we decide when, or it means at which value of F slidings will become initiate. Actually here there are two places of sliding to initiate. One is at the floor and other one is between the blocks. So here the important thing is what? To decide sequence of sliding on which containing surface sliding will initiate first. So that here is what intricacy, next level of intricacy introduced in this example. So first we see the direction of friction. Direction of frictional forces is apparent here. Here sense of sliding or its tendency is apparent. Thus direction of frictional forces on both the bodies are shown in the diagram. So we can see here force applied here. So friction on A will be backward and its reaction on A will be forward here, and friction from the floor on B will be backward. So that is what friction. On A it is a backward direction, on B this friction is forward, and from the floor the friction on B will be backward direction. So that is very simple. Now what is next thing? Sequence of sliding, that is important. What is sequence of sliding? Where sliding initiate first. First means it may give you sense of time. Actually in this problem we are increasing value from 0, value of F from 0. So at lower value of F where the sliding will initiate, we can say that is sliding will initiate there first, and where sliding initiate at higher value of F, we say sliding initiate there second. As the force F increases, the static friction at both the surfaces pair in contact increases and the smaller limiting value will be reached first. So sliding will initiate at the contact surface having smaller limiting friction. That is here somewhat simple. Now when you are increasing F gradually, both the static friction will increase simultaneously, because before sliding starts here on the ground, everything is in equilibrium. So as we increase F slightly, these two friction will be equal. So and again this friction will balance by this. So all these three friction will be equal and these three friction will grow simultaneously. Now which friction will achieve its limiting value first? That's of course that friction which has smaller limiting value. So their sliding will initiate first. So here in this case deciding sequence of sliding is straightforward, but this will not be always the case. So first we calculate the limiting frictions between the blocks. So we calculate limiting friction between A and B, F SMA mu MA into G. Here I denote the letter under the block. So limiting friction between block A and B, that is under the block A, so we designate by A. And similarly, limiting friction between block B and floor, that is under the block B, so we'll call it SMB. So now substitute the values. Mu is given, that is 0.6 into A is what, 10 kg and 10, so it is 60 Newton, straightforward. Now limiting friction between the block B and floor, we designate it by Fs and B. Mu into Ma plus Mb into G. Here mu is what? 0.3. So 0.3 into 10 plus 5.3 into 50 into 10. So again what? You can see it is 45 Newton. So both the limiting friction we have calculated. Now we can see thus sliding at the floor will initiate first. Because why? We have seen before sliding initiates, all the blocks are in equilibrium. So both this friction will grow simultaneously. So where it will achieve its limiting value, sliding will initiate first. So limiting value is smaller here at the floor. So at the floor, sliding will initiate first. Now on further increasing F, both the blocks will accelerate with the same acceleration till sliding between them initiates. And sliding between the blocks initiates when the static friction between them reaches its limiting value. Thereafter, accelerations of both the blocks will become different. So that is what? Logical solution, qualitative, what will happen? Now I am summarizing it. When the force will increase from 0, there is no sliding and all the blocks will remain in equilibrium and all the frictions will grow equally. Now the limiting friction we have seen is lower at the floor, so it will reach its value first. So at the floor, sliding will initiate first and that value we have seen 45 Newton. Now on further increasing force, there is no sliding between the blocks, but there is sliding at the floor. So both the blocks will accelerate with the same acceleration till sliding between them accelerate. Now at a particular value of greater than 45, sliding between the blocks will also initiate. At this value of F, the force of friction between the blocks will reach its limiting value. Now if further increase F, both the blocks will have different accelerations and friction between them will be kinetic. Now let's analyze the entire situation step by step. So first we decide when sliding at the floor initiate. The force F when sliding at the floor initiates. So here is the free diagram. We apply the force F. Now this friction will act in this direction. It will always be equal to F. And when sliding is about to initiate here, this force has become 45 value Newton. So this will be also 45. And these two forces will also be 45 because if it is 45, so to make an equilibrium, this force must be 45. So these two 45. Now this force is third law pair, this is 45. So to keep this block in equilibrium, this force must also be 45. So F is 45 Newton, say equation number 1. So at this value of F, sliding at the floor initiate and there is no other sliding. So before this value, accelerations of all the blocks are what? 0. NLM on the system of blocks before sliding between them initiate. Now if we increase force beyond 45 Newton, here sliding will initiate and both the blocks will accelerate simultaneously. But we are considering before sliding here initiate. So both the blocks will have same acceleration. Now we apply NLM on them as a system. So this is force F, this is 45 Newton, and this force is greater than, of course, that is 45 because they accelerate, but it has not reached its limiting value. So that is what? 15A, mass of both the blocks into A. So what we can write here? F minus 45 is equal to 15A, that is A means acceleration of A and acceleration of B both. So let us call equation number 2. Now we decide at which value of F sliding between the blocks will initiate. At this value of F, this friction has also reached its limiting value. The force F when sliding between the blocks initiates. Static friction between the blocks reaches its limiting value and blocks have the same acceleration. Now we can see here NLM on the blocks A. First we calculate block A because we have seen the force has here limiting value. So that is F, and here limiting value we have calculated limiting friction under A is 60 Newton. So it will be what? 10A. So how we can write 10A? 10 is the mass of the block A into A. So what is F minus 60 is equal to 10A, equation number 3. Now just we have seen that till this value of F when sliding between blocks initiates, both these blocks have same acceleration. So these two acceleration must be equal. So what we can write here further? From equation 2 and 3, eliminating A, will find F. So F is equal to 90 Newton. You can verify it. So at the value of F 90 Newton, sliding between the blocks will initiate. So what we can summarize till so far? Till F reaches a value of 45 Newton, there is no sliding and both the accelerations will be 0. And when F reaches 90 Newton, sliding between the blocks will initiate. Thereafter, increasing F, acceleration of both the blocks will be different. But when the force is in between 45 and 90, acceleration of the blocks are same and they are given by this equation. Now we summarize all these results. Accelerations with sliding between the blocks. So what we can see here, now F is greater than 90 and friction between the is kinetic. So we can separate block A and block B separately. So FKA is equal to 60 Newton, we have calculated earlier. So and FKB is equal to 45 Newton because these will be equal to value of limited friction because static coefficient friction and kinetic friction coefficient we have taken the same. So acceleration of the block A for F is less than 45 Newton. None of the blocks slides. Therefore, A of A is equal to A of B is equal to 0 because I have seen earlier that we are summarizing all the results. So before F is has reached 45 Newton, none of block are sliding. So both will be stationary and their acceleration will be 0. Now for the second range, F is greater than 45 but less than 90 Newton. Both the blocks will have same acceleration. So we can write here, both the blocks B slide on the floor but there is no sliding between them. So what we have, NLM on the system of blocks, we can write here this and here the friction at the floor. So what is the equation, kinetic diagram? Here 15A, mass of both the blocks, 5 plus 10, 15A. So we can write here A is equal to A of A is equal to A of B is equal to F minus 45 by 15, so F by 15 minus 3. So let us call equation number 5. Now when value of F is greater than 90, both the blocks will have same acceleration, so we separate them separately or we consider them separately. So accelerations of the blocks for F is greater than 90. Sliding at the floor as well as between the blocks begins. Thus, the blocks have unequal accelerations. So we apply Newton's law on both the blocks separately. NLM on A. So F here, the friction, this FK 60 Newton here. So equal to what? Mass of block A 10 into A. So A of A is F minus 60 by 10. So A of A will be F by 10 minus 6, equation number 6. Similarly, we can find acceleration of block B, NLM and block B. On block B, Fk is acting here forward and Fkb is downward, backward. So 60 Newton minus 45 Newton is equal to 5A. 5 is mass of block B, 5A of B. So A of B is a constant and you can see it is 3. How? 60 minus 45 upon 5 is 3 Newton. So now we have to write the results of what equation 4, 5, 6 and 7 simultaneously to prepare the graph. Accelerations of the blocks for all F, how we can summarize here. Representing equation 4, 5 and 6 and 7, we get A is equal to A of A is equal to A of B equal to 0, F is less than 45. A of A is equal to A of B is equal to F by 15 if F is greater than 45 less than 90. A of A is equal to F by 10 minus 6 and A of B is equal to 3 if F is greater than 90 Newton. All the results we have summarized, and now we are in a position to draw the graph. Now we have seen earlier that when coefficient of static and kinetic friction will be different, when the interval changes there will be discontinuity. Now when these values, the coefficient of static and kinetic friction are not different, at the change of interval there will be no discontinuity. We'll see here in the graph without any discontinuity. So here again on the ordinate we have numerical value of acceleration, and here on the axis we have numerical value of force, and the value you can see. So first range is what, 0 to 45, so here will be somewhat 45, then 45 90, here will be 90. So first we show this 0. So A of A is equal to A of B 0 till the value F is 45 Newton. Now when F is between 45 to 90, there is one equation again, A of A is equal to A of B, F by 15 minus 3. So this is the equation. Now you can see how it passes. So when F is 90, you can see 90 minus 90 upon 15 minus 3, it will be what, 3, is it? So that is what till 90 Newton both the acceleration are equal, but they are non-zero. Now as the force F increases beyond 90, acceleration of B will become a constant equal to 3, you can see here, and acceleration of A will be given by this equation and it will be here, and certainly slope of this equation will be greater than slope of this equation. You can see from here it is apparent. So again here we have explore all the possibilities, but in some situation you may be asked to calculate accelerations of the block at a particular given value of F. Even to solve that, you have to do all the things. You have to decide the sequence of sliding and the value of F where sliding in which pair of continuous surface occurs. Suppose you are asked to calculate acceleration of blocks at the force F is equal to 60 Newton. Even for that you have to find this value 45 and 90. You know that at 45 sliding at the floor will initiate, and at the 90 sliding between the blocks initiate. So value is given 6 Newton. So you have to use this equation. Similarly, if it were asked to calculate acceleration of blocks when the force F is 120 Newton, so you have to explore that is this 45 acceleration at the floor starts, at 90 acceleration at the between the blocks starts. So you are sure that at F equal to 120 Newton both the blocks have unequal acceleration. So you have to use these two equations. So in this way, what I have presented, the complete strategy of solving such problems. Let us come on the next example. Example 4. Two blocks A and B of masses 2 kg and 3 kg are placed on a horizontal floor as shown. Coefficients of friction between the blocks is 0.2 and between the block B and the floor is 0.1. So this is situation. Now you can see here two forces are applied simultaneously on both the blocks. If both the blocks are pulled simultaneously by forces of 5 Newton and 10 Newton as shown, find accelerations of both the blocks. Now at first sight this problem seems to be different than previous one, but what strategies we have used in the previous problems, the same thing we have to decide here. What we decide the sequence of sliding, at which value of forces sliding between floor and B will initiate, at which value of forces sliding between A and B will initiate. So suppose at these value of forces sliding between the block B and floor has been initiated, but sliding between the blocks A and B have not been initiated. So both the blocks will have same acceleration. But if at these value of forces sliding everywhere has been initiated, so both the blocks will have unequal accelerations. Now the most important thing is what? Decide sequence of sliding. For that we have to in a need of a limiting friction, and what we do, we calculate frictions required to prevent sliding at the surfaces and compare them with the limiting friction. Now we do the same thing. So first we have to know the limiting friction. Let us calculate them. Limiting frictions between the surfaces between the block A and B, what we call FSMA. is equal to mu into mag. Mu is what? Coefficient of friction here. And A I'm using here under which block? So it will be 0.2 into what? 2 into 10, so it will be 4 Newton. Between the block B and the floor, we designate by FSMB because it is under the block B. So FSMB is equal to mu into MA plus MB into G, because here normal direction will be equal to weights of both the blocks. So FSMB will be equal to what? 5 Newton. You can verify putting the values. How? 0.1 into 2 plus 3 into 10, it will be 5 Newton. If you look at these values, these two friction forces and these two forces, it is apparent that what the sliding... If you look at these two friction forces and these two values, you can think that if you look at these two friction forces and these two values, you can easily think what I am concluding here. It is apparent that the block B will slide on the floor, but it is not apparent that whether there is sliding between the blocks or not. Hence the sense of this sliding or tendency of this sliding. Actually, see here, this limiting friction is 5. So this 10 Newton force will easily overcome this force. So on the floor, certainly there is sliding. But whether there is sliding between the blocks or not, it is not apparent. So we will decide whether sliding between the blocks or not. For that, we will use the same strategy. What we do, we calculate required friction here to prevent sliding, and then we compare it with the limiting friction. We can do one thing, or we can calculate accelerations of these two blocks assuming friction here 0. These acceleration will show us tendency of sliding, means certainly there is static friction. So if you want to decide direction of static friction, what we do, assume friction to be absent here, but you have to assume friction here, calculate the acceleration of these two blocks, and then relative acceleration. That relative acceleration will show you tendency of sliding, first thing, and then by calculating required friction to prevent sliding, we can decide whether there is sliding or not. So now we calculate accelerations of the blocks assuming no friction between them. Means we have to assume friction only here to be 0, because at this point we have to decide tendency of sliding. So on block A there is only force of 5 Newtons, so its acceleration is what? 2 mass, and A of A mu assume 0. It shows here only here we are assuming mu 0. So A of A is equal to 2.5 meter per second square. Similarly, assuming mu here 0, we calculate acceleration of block B. So here this limiting friction will keep on acting, and here limiting friction is equal to kinetic friction, so we assume it kinetic friction. So this 5 Newton backward and 10 Newton forward. So what we have, mass of this block 3 into A of B assuming mu 0 at this contacting surface. So what we calculate, A of B mu 0 is equal to 1.67. These two accelerations shows that this block A has tendency naturally to move ahead of block B. So the block A will try to slide on the block B in forward direction. So sliding tendency here on block A is forward direction. So friction of static will act on A in the backward direction and on B in forward direction. Relative accelerations of the blocks suggest the sense of sliding between the blocks or its tendency. Thus, friction on the blocks A is backward direction and on B it is in forward direction. Why I have shown here, told you sliding or tendency sliding, because I am not sure. At present we are not sure there is sliding or not, but we are sure yes there is friction. If there will be friction, the friction will act in this direction. Now we decide whether there will be sliding or not. For that, what we do, we calculate friction required to prevent sliding here and compare it with its limiting value, what? 4 Newton. Now to decide whether there is sliding between the blocks or not, we find the required friction to prevent this sliding and compare it with the limiting friction between the blocks, that is 4 Newton. So if there is no sliding between the blocks, they will have the same acceleration. Actually, if we are assuming friction required to prevent sliding, it means we are assuming there is no sliding, so they will have same acceleration. Now what we can do, friction required to prevent sliding, let us calculate. For that, we assume their acceleration to be same. NLM on the system of blocks, because we are assuming acceleration same, so we can assume them as a system. So we show only horizontal external forces, 5 Newton, 10 Newton, and here FSM 5 Newton. So that will be what? Mass of the blocks, sum 2 plus 3 into A. So here what you get, A is equal to 2 meter per centimeter square, very easy. 15 minus 5 upon 5, A is equal to 2 meter per centimeter square. Now to have this acceleration, let us calculate what is required friction here. So we can consider block A and block B, either of them. So let us consider the block A. So block A, force is 5 Newton, and here limiting friction we will not take, we take required friction is equal to mass of block, how much, that is 2 kg into acceleration A. And this acceleration must have the same value. So 5 minus FRE is equal to 4. And we put the value A here, what you get, 4. So from equation 1 and 2, what you get, 5, that is 5 minus FRE is equal to 4. So FRE is 1 Newton. And the required friction to prevent sliding is well below the limiting value 4 Newton. So there will be no sliding between the blocks and both will have same acceleration. Now this acceleration will be equal to 2 meter per centimeter square. The friction required to prevent sliding between the blocks is smaller than the limiting friction 4 Newton. So there is no sliding between the blocks and the blocks will move with the same acceleration, and that acceleration will be given by this equation. This acceleration is given by the equation 2. So what we can write here, A of A is equal to A of B is equal to 2 meter per centimeter square. Now we have seen this problem somewhat different. Now, but the solution strategy was the same as we have done in previous problems we have taken as a model example. What the most important thing is what to decide direction of frictional forces and sequence of sliding, and to at what value of forces sliding will initiate. For that, the litmus test was what? To assume no sliding and calculate friction required to prevent sliding. If this friction required to prevent sliding is more than the limiting friction, there will be sliding. If this friction required to is less than limiting friction, there will be no sliding. Now we take the same example with somewhat different value of forces so that there will be sliding. I am saying there will be sliding, but by observing the value, you cannot say whether there will be sliding or not. So let us come on the next example. Example 5. Two blocks A and B of masses 2 kg and 3 kg are placed on a horizontal floor as shown. Coefficient of friction between the blocks is 0.2 and between block B and the floor is 0.1, the same data. But the forces I am assuming different. Here 15 Newton and 50 Newton. If both the blocks are pulled simultaneously by force of 15 Newton each as shown, find accelerations of both the blocks. Now you cannot say whether there will be sliding between A and B or not, because by merely saying that if this force will be equal to greater than this limiting friction, there will be sliding. You cannot say, because in the previous problem the limiting friction was 4 and this force was 5 Newton. So merely comparing here limiting friction and this force, you cannot say whether there will be sliding or not. For that you have to do the same thing. You have to calculate the friction required to prevent sliding and compare it with the limiting friction. So now let us proceed with the solution. We calculate as earlier limiting frictions. So between the blocks, the limiting friction is what? FSMA. I'm using A because it is under the block A. So this notation I'm using here. So mu into MA into Z, and it was earlier as it was 4 Newton. And between the block B and the floor, we designated by FSMB because it is under the block B. So F SMB is equal to mu into MA plus MB into G, because here normal direction will be equal to weights of both the blocks. So F SMB is 5 Newton. As used earlier, it is apparent that block B will slide on the floor, but it is not apparent that whether there is sliding between the blocks or not. Hence tendency of sliding, and hence sense of this sliding or its tendency. Actually, by observing this value, we cannot say whether there is sliding between the block and B. If we cannot say there is sliding, so we cannot predict tendency of sliding as well as its sense, its direction. And to decide direction of friction here, what we do, we calculate accelerations of both the blocks, assuming friction to be here 0. At which surface we are investigating friction, assume friction 0 there and nowhere else. Now calculate acceleration. For this, we calculate accelerations of the blocks assuming no friction between them. So at A there is only force 50 Newton, and it is what mass of A into acceleration of A. So 2 A of A mu 0. Mu 0 means only here mu 0. So A of A is what? 7.5 meter per second square. Similarly, we calculate A of B, that is 50 Newton and 5 Newton here. So what we have, 3 A of B mu 0, that is what? A of B mu 0 is equal to 3.33 meter per second square. These two accelerations will show the sense of relative motion. And it is apparent that friction on A will act in backward direction and friction B will act in forward direction, because these two frictions will be Newton's third law pair. Relative accelerations of the blocks suggest the sense of sliding between them or its tendency. Thus, friction on the block A is backward and on B it is forward direction. So direction of friction we have decided. Now we'll decide whether there will be sliding between A and B or not. For this, as I have told you earlier, what you have to calculate? Calculate friction required between A and B to prevent sliding and compare it with the limiting value 4 Newton. To decide whether there is a sliding between the blocks or not, we find the required friction to prevent this sliding and compare it with the limiting friction. Now what we do, if there is no sliding, both the blocks will have same acceleration, because we want to calculate friction required to prevent sliding, so there is no sliding, so both the blocks will have same acceleration. And if both the blocks have same acceleration, they can be treated as a system. Friction required to prevent sliding between the blocks. So we apply NLM on both the blocks because they have same acceleration easily. NLM on the system of blocks, only horizontal external forces are shown, vertical forces no need to show. So that will be equal to total mass 2 plus 3 into A. So A is what? 30 minus 5 upon 5. So A of A is what? 5 meter per second square. Very easy to calculate. Now applying NLM on block A, we will calculate the required friction. NLM on the block A. So 15 forward and required friction backward. We have seen that friction will be in backward direction earlier. This will have the same acceleration. What? Mass 2 into this 5. So what equation we get here? 15 minus F RE is equal to 2A. And we substitute these values, or we can say by equation 1 and 2 what we get. From equation 1 and 2, what? 15 minus FRE is equal to 10. So what FRE is equal to 5 Newton. So required friction here is certainly above or more than the limited friction 4 Newton. So there will be sliding. So both the blocks have different acceleration. So we can apply Newton's law on them separately, and our friction will have their kinetic values. So what we can conclude, the friction required to prevent sliding between the blocks is greater than the limiting friction 4 Newton. So there is sliding between the blocks, and the blocks will have unequal accelerations. Since there is a sliding at both the pairs of surfaces in contact, frictions, there will be kinetic frictions. Now the things are very clear. We can calculate accelerations very easily. So Fka is equal to Fsma is equal to 4 Newton, because mu s and mu k both surfaces are equal. So Fk under B will be what? Fsmb is equal to 5 Newton. Now we apply Newton's law. Now the accelerations of the blocks can be calculated by applying NLM on both them individually. Let us see how we can apply this Newton's law. NLM on the block A. So 50 Newton forward and kinetic friction 4 Newton backward, that is equal to kinetic diagram, mass 2 into A of A. So what we have, 15 minus 4 is equal to 2A of A. So A of A is what? 5.5 meter per second square. So what is 11 by 2? 5.5. Similarly, we can apply Newton's law on block B. An element on the block B. So on block B, this force was 50 Newton applied. So this force friction was backward. So here it is forward, and this friction was backward. We have seen. So what equation we have here? Kinetic. Let us show kinetic diagram. Mass 3 into A of B. So equation is what? 15 plus 4 minus 5 is equal to 3A of B. So what is remaining here? That is 14 equal to 3 of B. So A of B is equal to 14 by 3. So it is 4.67 meter per second square. So both the accelerations we have calculated. Now let us write them. Acceleration of the blocks. A of A is equal to 5.5 meter per second square, and A of B is equal to 4.67 meter per second square. Now, till so far, for whatever complexity a problem has, we have seen all the critical decision points and what they are. I am again suggesting deciding direction of friction. If it is apparent, then write it. If it is not apparent, try to find accelerations assuming friction 0 at the surfaces in contact under investigation, and then calculate relative acceleration, and that relative acceleration will suggest us sense of sliding and sliding tendency. So direction of friction, in that way we can decide. Now next thing is what? To decide the sequence of sliding. So at which surface we are to decide sequence of sliding, or sliding will be there or not, what you do? Assume there a required friction to prevent sliding. Calculate that required friction. If that required friction is greater than the limited friction, there is sliding. If it is smaller than limited friction, there is no sliding. Now we have almost a clear-cut idea of taking decisions and their sequence in such kind of problem, and we are well equipped to take some higher order problem. Let us discuss a 3-block problem. Example 6. 3 blocks A, B and C of masses 1 kg, 2 kg and 2 kg are placed on a horizontal floor as shown. Coefficients of friction between the block A and B is 0.5, between the block B and C is 0.2, and the floor is frictionless. So this is setup given here, A, B, C. Here block A is of 1 kg and block B and C both are of 2 kg. Coefficient of friction between A and B is 0.5 and between B and C is 0.2, and the floor is frictionless, and force is applied here on block B horizontally towards right. First A, find maximum value of F for which there is no sliding between the blocks. Actually, what you find? The maximum value of force F at which there is no sliding anywhere between the blocks. Of course, the floor is frictionless. So as we slightly increase the force F, there will be sliding at the floor, and both the blocks will keep on moving with the same acceleration, and friction between them will go on increasing as we increase F. So what is we to decide in this problem? The maximum value of F for which there is no sliding between the blocks. It means all the blocks are moving with the same acceleration. So again we would see the direction of friction, direction of frictional forces. Here sense of sliding or its tendency is apparent, or it may be estimated very easily. Thus direction of frictional forces on both the bodies are shown in the diagram here in this way. This force applied here, so this friction on A will be in forward direction, on B will be in backward direction. So here again, this friction will forward and this backward. How we can decide it? Whether by finding relative acceleration, assuming friction to be 0. Because if you assume friction to be 0, this block F will move forward, this will remain here, this will remain here. So here this block B will move forward as compared to A, so friction will on B in backward, so here will be forward. Similarly here. Or you can have some other strategy. What? If you observe this system, certainly it will accelerate, but and again we are assuming there is no sliding between the blocks, so A and C will have same acceleration. So only force providing acceleration to A can be friction, so it will be in forward. Similarly, only force providing rightward acceleration to C is friction, so it will be in forward direction. So these two friction will be opposite. So either the way you can use to decide direction of friction. Limiting frictions between the blocks. Let us calculate these limiting friction, because their value will be necessary to solve the first problem. What? Maximum F for which there is no sliding. So limiting friction between A and B. So what we call F SMA mu mag, very easy. So it will be what? 5 Newton. So you can verify the values. How you can see? MA is what? 1 kg and it is 0.5. So 0.5 into 1 into 10, 5 Newton. Similarly, limiting friction between the block B and C. So what we call it? FSMB, because it is under the block B. So to create this friction, both of block A and B, their weight will create the required normal direction. So this normal direction, what? MA plus MB into G, and mu here. What is mu? 0.2. So 0.2 into, that is what? What is 0.2 into 1 plus 2? 3 plus 10. So it is 6 Newton. So both these limiting friction we have calculated. Now we think somewhat here. The floor is frictionless. Thus, as the force F increases from 0, all the blocks move together without sliding between them. That is, with the same acceleration, till sliding initiates between any two of them, because we are not sure at which contacting surface sliding will initiate, between A and B or between B and C. But before sliding initiate anywhere between the blocks, all the blocks will have same acceleration. Sequence of sliding, where sliding initiates first. As force F increases, the friction required to prevent sliding, static friction basically, at both the surfaces in contact increases. Sequence of sliding is the sequence in which static friction reaches its limiting value. So now we calculate, assume acceleration same, the friction required to prevent sliding at both the surfaces. Which surface limiting required friction will reach the limiting value first? There will be sliding first. Friction forces required to prevent sliding between the blocks. NLM on system of blocks A, B and C. So A, B, C, F is here. So what we can see, acceleration we are assuming same. So mass of A plus B plus C, 1 plus 2 plus 2 into A. So we can see here F is equal to 5A, equation number 1. NLM on the block A. So on block A, FSRE, we assume static friction required to prevent sliding. A, that is only force here. So what it will be? Mass into acceleration, mass is 1. So we write A. So here FSRE is equal to A, equation number 2. Similarly, NLM on the block C. So here block C, there is only this FSREB, that is under block B. So it will have mass into acceleration, mass is 2 into A. So 2A. So what we have here? FSREB is equal to A, 3. That is what? Now what we can think? Expressing the frictional forces required to prevent sliding in terms of F with the help of equation 1, 2 and 3, and then comparing with the respective limiting friction, we can decide sequence of sliding. So what we can write here, we can see FSREA will be F by 5. It should be less than or equal to 5, because here, what we have this Instead of A, if you write this FSRE, so it will be what? F by 5. Similarly, what you can write? FSRE at B is equal to 2F by 5 less than or equal to 6. You can see. How? Because here, that is instead of A, what we have? FSRE by 2. So it will be 2 go here and A will be here. So this 5 will be here in denominator. So you'll get this one. Now you can see from here which force required limiting value reaches limiting value at lesser value of force F, which is apparent from these two equations. Static friction required to prevent sliding between B and C, FSREB reaches its limiting value at smaller value of F. So the beginning of sliding between them will become earlier. What you can see. Now F from here is 25. F from here is what? 15. So this FSRB will reach its limiting value at lower value of F. So friction between B and C will become first at smaller value of F. So you can see how we can decide sequence of sliding. Thus, maximum value of F for which there is no sliding between the blocks is decided by FSREB. That is very critical reason, and that maximum value is 50 Newton. So FSREB is equal to 2F by 5 is less than 6. So that will be less than or equal to 50 Newton. So till the force F reaches value 50 Newton, there is no sliding between any pair of the blocks, and all the blocks will have same acceleration. So this was the part A. So first sliding will initiate between block B and C. Now we have to decide in the, let us say, next part, at which value of force F sliding between A and B will initiate. So that is I'm writing here result for F is equal to 50 Newton, sliding between block B and C begins. So let us discuss part B. Find maximum value of F for which there is no sliding between the blocks A and B. Till so far what we have seen, that when the force reaches a value 50 Newton, there is sliding between B and C which starts, but still sliding between A and B has not been started. It means when we increase force beyond 50 Newton before sliding between A and B start, A and B are moving with the same acceleration. But let us see how we proceed with the solution. For F is equal to 50 Newton, sliding between the blocks B and C begins. That is the result obtained in the previous problem. And what it has further interpretation. For some value F greater than 50 Newton, sliding between blocks A and B will begin. Means to initiate sliding between A and B, the force must be greater than 50 Newton. When sliding between blocks A and B is about to initiate, they are moving with the same acceleration. That is again very clear. Now we have to calculate friction required between A and B to prevent sliding and compare it with its limiting value. FSMA is equal to 5 Newton, which we have calculated earlier. So what we assume? We assume block there is no sliding, and we calculate the maximum required friction to prevent sliding between A and B. So what we have, NLM on the system of blocks when sliding between them is about to initiate. Till that moment, both the blocks have same acceleration, and at that moment we assume the friction required has reached the limiting value in between them. But we assume here NLM on block A and B, but here is sliding. We are sure that there is sliding between B and C, so we assume its kinetic value, and that is equal to FSMB 6 Newton. So what we can write kinetic diagram, that is 1 plus 2 into A. So from here what is the equation? F minus 6 is equal to 3A. So let us call equation 1. So that is what we have written Newton's law equation on the system of block A and B, assuming no sliding between them. The friction required between A and B to prevent sliding, what it will be? NLM on the block A. Let us calculate, apply NLM block A, because it was somewhat simpler because only frictional force is acting on it. So if you assume if FSREA means required friction to prevent sliding, so this will be what? Mass is 1 into A. So what we have? FSREA is equal to A. Now from equation 1 and 2, what we can get? Expressing the friction force required to prevent sliding in terms of F with the help of equation 1 and 2, and then comparing with its limiting value. So what we can write here, you can see very easily, FSRE is equal to F by 3 minus 2, and it should be less than 5 Newton. But if it be equal to 5, sliding will initiate. So by using here equality, so what you get here, F by 3 minus 2 is equal to 5. So F by 3 is equal to 2 plus 5, 7. So F is equal to 21 Newton. So when this force will reach its value 21 Newton, sliding between A and B will also begin. So F is less than or equal to 21 Newton. Now part C. Find accelerations of the blocks for F is in between 0 and 50 Newton. Now for this, suppose this individual problem was asked, find acceleration of the block when force applies is 10 Newton. But even to solve that problem, what we do, we have to solve all the two parts what we had done earlier, A and B. When at which value of force sliding will initiate between B and C, and at which value of force sliding will initiate between A and B. Now what we do here for this problem, results of previous parts to be used. What are the results? Direction of frictional forces and their limiting values. So we are again rewriting them. F applied here, so friction here will be forward, here will be backward. Again here will be forward on C and B backward. So these are the direction of frictional forces. Limiting values of frictional forces between the block A and B, that was FSMA 5 Newton, and limiting value of frictional force between the block B and C, that was FSMB is 6 Newton. Till these two things we have calculated earlier. Now there is no sliding between the blocks. What the result? All the blocks move with the same acceleration. If there is no sliding, all the blocks will have same acceleration, and sliding between the blocks has occurred between B and C first at 15 Newton and between A and B at 21 Newton. So if the force is between 0 to 50 Newton, there is no sliding between the blocks and all the blocks will have same acceleration. A of A is equal to A of B is equal to A. And now we can apply Newton's law on the entire system. So we show only the external force horizontal. So that is F. That is what? 1 plus 2 plus 2 into A. So what is equation? A is equal to F by 5. So what we can write here? A of A is equal to A of B is equal to A of C is equal to F by 5. Now we can see the D part. Obviously the D part is what? When the force applied is between 15 and 20 Newton, what are the accelerations? Now, even if this part were asked individually, you will see that part A and B you have to do. And by using result of part A and B, we know that for this range of force, sliding between A and B has not been initiated, but sliding between B and C has been initiated. So let us see how we can proceed further. Results of previous parts to be used. What? Direction of friction and their limiting values. I'm again writing them. So direction of friction is obvious this way and that way. And limiting values, again we know that limiting friction between the blocks A and B, FSMA is equal to 5 Newton, and limiting friction between block B and C, SMB was 6 Newton. So FSMB is 6 Newton. Again what? There is no sliding between the block A and B, but B slides on C. That is what result, what we have done in previous parts. So what we can see, A and B will have same acceleration, and of course acceleration of C will be different. So A of A is equal to A of B is equal to, let us call A. Now we have to apply Newton's law on the system of blocks A and B. NLM on the system of blocks A and B. So we draw the FBD. We show only the horizontal actional forces. So F was applied on block B and friction kinetic between block B and C, that will be equal to limiting value because mu S and mu Q are equal. So here 6 equal to mass of block A plus B, 1 plus 2 into A. So what we can write here, A of A is equal to A of B is equal to A is equal to F minus 6 by 3. So F by 3 minus 2. So that is the result here. Now what we to calculate acceleration of block C. There is sliding between the blocks B and C. So block C has to be taken individually. An element on the block C. So for block C, only this force is acting in forward direction. So FSMB in forward direction is equal to what? Mass of C into AC. So AC is a constant 3 meter per second square. So this part has also been clearly completed. Now we can make a next part. What? If F is beyond 21 Newton, what will be acceleration about the blocks? Let us make it part E and solve it. Find accelerations of the blocks for F is greater than 21 Newton. Now you can think that solving these problems in tandem, one after one, several parts, it will become somewhat simpler. But in exam or anywhere, you may be asked any one of the part individually. Suppose this part has been asked individually, assuming or stating value of F 30 Newton. Even then, you have to decide whether the sliding between all the blocks has been occurred or not. So part A and B were having utmost important. Now let us see to proceed with that. We assume that previous parts we have done. So what result we can take from the previous part, we again write it. So in solution here, results of the previous parts to be used. What results? The direction of friction and limiting value, and for which value of force sliding start where. So direction of friction and forces and the limiting values. So here direction of force on A forward and here B backward, and again here on B backward, on C forward. Say this way. Limiting values we have seen earlier that between block A and B, this is FSMA is equal to 5 Newton, and between B and C, what it is? FSMB is equal to 6 Newton. And we have seen that till 50 Newton force F, there is no sliding between the blocks, and at 50 Newton sliding between B and C initiates, and at F is equal to 21 Newton sliding between A and B also initiate. So when F is greater than 21 Newton, sliding between all pairs of contact has been initiated, and all the blocks have different accelerations. There is sliding between all the blocks because this is the result we have taken. We take from the previous parts. So all the blocks will have to separate acceleration. So A of A is not equal to A of B is not equal to A of C. So we treat all the blocks individually and apply them, Newton's law on them. So NLM on the block A. So what? Only the force of kinetic friction, and it is equal to value of limiting friction. So I'm writing a FSMA 5 equal to mass into acceleration A of A into 1. So what it will be? A of A is equal to 5. Similarly, NLM on the block B. So on block B, only external forces, horizontal F, this friction F, FSMA 5 Newton backward and 6 Newton backward. I'm using this symbol. Of course, they are kinetic friction, but their value is equal to limiting friction. So equal to mass into acceleration 2A of B. So what will be A of B? F minus 11 by 2. So F is equal to A of B is equal to F minus 11 by 2, or you can say F by 2 minus 5.5. Similarly, an element block C. On block C, only this force 6 Newton is acting. So that will be mass 2 into A of C. So A of C is clearly 3 meter per second square. So when force is greater than 20 Newton, all the blocks have separate acceleration. Now we can summarize all the results in another part by showing all the results on a graph. Draw a graph between accelerations of the blocks and the force F for all values of F. Now this is very important, and this graph we'll see critically at a glance will explain all the phenomena. Solution: what we do, results obtained in the previous parts. What results? We can summarize values of acceleration. A of A is equal to A of B is equal to A of C is equal to F by 5 till F is less than 50 Newton. And A of B is equal to A of A is equal to F by 3 minus 2, and A of C is equal to 3 till F is in between 15 and 21 Newton, and A of A is 5. A of B is F minus 11 by 2, and A of C is 3 when F is greater than 21 Newton. So all these things we can draw on a single graph. Again here, on the ordinate we take a numerical value of acceleration, and on the abscissa we take numerical value of the force. You can see the values 10, 20, 30 and 40. 1, 2, 3, 4, 5 up to 10. So where discontinuities are occurring, means where the intervals are changing their definition. At F equal 15, say here, and F equal 21, say here. So till 0 to 15, all the acceleration have same value, F by 5. So it will be a line inclined with positive slope passing through the origin. So this way. So say this 15 Newton till that all the acceleration are equal, and the definition is F by 5. Now as the force increases beyond 15 Newton, acceleration of block C will become constant. It will be 3. And acceleration of block A and B are given by this equation. So we are showing here this acceleration of C will become constant, and A of A is equal to A of B is equal to F by 3 minus 2 at value of 21 Newton. Now as the force increases beyond 21 Newton, acceleration of A also becomes constant. Acceleration of B has also become constant. So this acceleration of C has become constant. So acceleration of B is given by what? F minus N by 2, this one. Acceleration of A is 5, constant, and acceleration of C was already constant. So this graph will give you all the happening at a glance. Now what I feel personally, that these 6 model problems are sufficient to explain you every intricacy on these problems. So what I suggest you, before you attempt any other problem, try to understand all these problems critically, one thing, and wherever you find a difficulty, try to search similar decision taken in any of the 6 problems. So now we are well equipped with Newton's law of motion, and decide homework for today. First thing, revise all the ideas covered and all the examples discussed in this lecture, because these 2 or 3 problems are very confusing at first. But if you try to understand all these model 6 problems, what we taken an example here, you can solve every problem. Suppose sometimes you have some confusion, search which kind of problem you are taking and you are being confused, match with any of the example and see the example first and again do it. Certainly you will find solution of the problem in which you have been finding trouble. And now of course everything about Newton's law has been covered, so we can have homework from SCV. We can complete the friction chapter from SCV, attempt exercise of chapter 6 of SCV, all the worked out examples, because earlier I had not recommended you to complete the worked out example. Now I recommend you first complete all the worked out example given in SCV, but don't see their solution. Try to solve by your own. Question number 21 to 31, because 1 to 20 we have done earlier. So now complete the exercise. So in this way, a formal discussion of Newton's law has been covered. In next lecture, I will discuss few problems from Pathfinder on friction. Thanks for patient listening today. We'll meet in the next lecture. I am never content until I have conceived a model of what I am studying. If I succeed in making one, I understand, otherwise I do not. Sir Lord Kelvin.